All right, welcome to the after work video. There was unfortunately some sort of issue with the lunchtime video. I'm like super zoomed in for some reason, but there was an issue where I lost the video. It wasn't too, I think, groundbreaking of a video. I did end the video before it with a question that I did end up answering in quite a bit of depth in the lunchtime video. But I can give the kind of short story of that, and that's when I applied that firewall filter onto the loopback interface. It dropped all of the OSPF neighbors between router 1 and the other routers. So if I did a show OSPF neighbor on router 1, it had no OSPF neighbors. But then if I took that firewall filter off, it actually only reestablished one of its OSPF neighbors, but it was still able to advertise all the necessary networks, and then connectivity was restored to all of the other routers. So I still don't have a good handle on why that is the case, because loopback 0 is when you do the show OSPF neighbors command, it's not that IP on loopback 0 is not the target. So the only time the IP on loopback 0 shows up in OSPF packets, hello packets, is when it is sent from the router. Now I do know that OSPF does use unicast as well as multicast. So now that I think of it more here in this next video, the after work video, I think that might be the reason, because the unicast traffic was having an issue, the OSPF unicast traffic. So I'm going to make sure to share my screen here, and yep, everything's still running. So this would normally be video 5, but I lost the other video. So we're just going to have this be video 4, and then that video is no longer going to be there. But what we're going to do in this video is go through these examples, because that's the other thing I did in the lunchtime video, is that I just picked out some examples I can do in the next video to learn more about firewall filters. So we'll go through these, and this will hopefully be the end of this subject, and then we can move on to the next topic, which will be automation scripts. All right, so let's pull up the lab. So here's the lab, and I had a Wireshark capture going. So let's just do an assessment of where it is now. I actually forgot. So I have everything still installed on here. Let's do a screen-r. There we go. So yep, we still got the Radius server going. Let's log into to router 1. Okay, we're already logged in. So yeah, let's just detach the screen and then just see if we can ping everything. Yep, we ping that, ping this, and then I'm sure we can ping everything else fine. So let's do show OSPF neighbors. So we've got a neighborship which is enough to advertise all of these routes. I am surprised that there's only one neighborship. So let's do a show in description, pipe match 0, 0, 0. Okay, so there's only one neighborship to router 2. So I've got router 4 open now, so I will see what the issue is. Maybe the ports are shut down. So the ports are up. Maybe there's a problem with connectivity. Aha, yep, so that's the problem. I can't ping across the links. Oh, so it looks like this one's fine, but let's investigate the problem here. So show in description, pipe match So this is router 3 where there's a problem. And router 3 I don't have radius set up on, so I will just use the root account. I don't have other accounts set on either. I'll take a look at the running config. So yep, everything looks pretty good. Now, I do have the IP configured. On router 3, but this is on GE000. So let's verify that this is actually, yep, so router 3 is going to be 000. Router 1 is going to be 002. So let's verify router 1, 002. Aha, so this looks like it's the problem. If I do a show int description, pipe match R3, the port that I configured as the port going to R3, so this port here is incorrect. I'm going to need to configure GE002 instead of GE001. It's just 2 less than the number in the topology is the number on the box. So, but let's see if, first of all, see if there's configuration on GE002. Okay, so this is meant to be going to 4, and if I do a show Ospf neighbor and then a show int description, pipe match, we can see we've got no issues with the Ospf neighborship to router 2. We've only got an issue between router 3 and router 4, and that makes a lot of sense because these are actually flipped. So router 2 goes to, so port 2 on router 1 goes to router 3, but port 1 on router 1 goes to router 4. So they're flipped. So really easy to fix. So let's go to port 1 first, and this is the power of that command, show pipe display set relative, because we get the whole config relative to where it is, so we don't need to go into Notepad, doctor it up, anything like that. Okay, and the reason we don't need to do that is because we can just go into the hierarchy here, do a delete, and now we can take what was under GE001 and we can paste it directly under. Since it's relative to the hierarchy, we're not including extra configuration. So now I can do an up, and I can go into GE001, and now I can do the same thing, but with what was under GE002, and I can flip the configuration of those interfaces. Really nice and easy. I don't even need to doctor it up in a Notepad. It's accurate, it's safe, and it's fun. I would say it's fun for sure. I'm having fun right now. So, yep, it looks like everything's flipped. So let's commit and quit and see if those neighborships come up. Oops. Oh, but remember, it's a little bit different with Junipers. Oh, wait, but I thought I did a delete. Oh, maybe I forgot to do the delete on router 1. I think I probably did, yeah, you can see I did, because I did it right here under interfaces 2, but I forgot when I went here to do it under interfaces 1. But that's nice and easy, just edit interfaces 1, delete, yes, and then grab that from interfaces 2. There we go, top, show pipe compare. So now we've got an extra line here where we're removing the address. Up here, oh, sorry, it wasn't there, but it was under GE001. But you can see we've only got a line adding the address, and then we can see the address we previously got. But here we've got a line adding and removing from GE001. So let's get a better sense for this message. Identical address found on multiple private or public interfaces. 001. So yep, sure enough, we've got 10.0.1.1 on GE1 because we never removed it. But then we're attempting to add it to GE2. But we can't have an identical address on two different interfaces. We can have multiple different addresses, which is different from Juniper, but we cannot have identical addresses on multiple interfaces. All right, so commit and quit, and then hopefully those Ospf neighborships will come up. So show Ospf neighbor, pipe match, or sorry, not pipe match, pipe refresh one, because I want to, oh, so we'll see this go from xtart to full. Perfect, okay. I'm kind of curious if there's a help apropos for xtart. Nope. All right, so yeah, all the connections are up now. So let's put that firewall filter back up and let's see how it's going to affect the traffic. So before we do that, we'll start a Wireshark capture. Okay, and then we'll go on to the guest. So this is going to be guest 1. All right, and then we'll do a continuous ping to 172.16.0.4. Oh, and there's no guarantee that it will go down that link. So probably going to want to sniff the link that it goes through. We can figure that out by doing a trace route. Yeah, and we'll just sniff the link that the Icmp traffic goes through. Okay, so it's going to go let's see here. So it's going to be should be going through that link. Because otherwise it'd be an extra hop if it were going through any link but this link. There would be more than just 2 hops. Here's just a hop here and a hop there. So I'm surprised I didn't see any Icmp traffic here. Let me try this again and see if that Icmp traffic shows up. Maybe there's just a delay, or maybe it was that bug where it stops. Okay, yeah, so it was just that bug where it stops keeping track of the traffic. So let's now apply that firewall filter and see how it changes things. We're going to do it on input, and we're going to restrict management access. and it's going to be from anything with this source address. Sorry, no, we're going to allow management access from anything with the source address. So this is kind of a bad name. Doesn't really describe what this is specifically doing. It describes more the spirit behind it, but not what it actually ends up doing. So here's the hello packets. So if these were being sent to the loopback address in any way, then they would now be rejected. The loopback address would not be able to process these packets because the source address on them is not what is permitted in the firewall filter. And there's some crazy helicopters, so I'm going to go look at this. Oh, if I don't trip and fall. Okay, well, that was loud and distracting. All right, so let's see what's going on here. So now we've got these hellos again. Yeah, so I'm going to go back to, back to R1 and do a show Ospf neighbor. Yep, and there we go. We can see all our Ospf neighbors went away, and that's because I've got a filter on loopback 0 that is disallowing traffic ingress that has a source address that does not match this. So assuming that Ospf control traffic needs to go to loopback 0 in order to have a Ospf neighborship, that is going to be enough to drop those connections. So I think I learned something today. And what I learned is that even though you're not explicitly sending Ospf traffic to a loopback address, the loopback interface is still involved in it somehow. And I wish I knew more about that. One thing I can do is go configure privates and go edit interface LO0.0 and then edit family inet filter. And if there's any trace options, anything like that, what I can do is enable those and then do a monitor start and hopefully see what is happening. So we got trace options here. But I don't think there's any trace options for the firewall filter. Okay. All right, so yeah, I'm not sure how to have trace options, but the good news is that if I just kind of stick to the plan and don't go off the rails with kind of my own plans and follow through these examples, I think I'm going to get much nicer exposure to firewall filters than I'm getting now, where I'm just kind of trying to go off the rails and figure it out on my own. So I'm going to cancel, well, I'll keep that going, and then I'll do a rollback one, show pipe compare. So I'm going to take that filter off, and then we'll see my pings will start going through after those neighborships are back. There we go. So now the neighborships are back. There we go. So let's clear off that firewall filter that I put on there. Oops, which was named restrict management access, even though the action of the filter is to allow management access, so really poorly named. But it's going to allow it from this source address, and then it's going to restrict it from anywhere else. So I don't know, there's an argument to be made that it's a good name, but it did not function as intended. So I would kind of side on the argument that this is just not a good firewall filter. So let's go through the examples and see what Juniper recommends. So this is the example, configuring logging for a firewall filter term. Okay, so this would be really good. Well, I mean, we know what's going to happen. So this example shows how to configure a firewall filter to match packets. In this example, you use a firewall filter that logs and counts Icmp packets that have as either their source or destination. Okay, so we'll not be using this. We'll use the packet. We'll use the guest1 IP. So let's just put it side by side and type it out. So let's do this on router 4, just so we can, if we want to sniff the links, we can have a wider variety of links that we can choose from. All right, so yep, now it's time to set up the firewall filter to match traffic coming from the Ubuntu Docker guest. So the IP is going to be 192.168.0.2. Don't allow any user to read the log file. So that's interesting because I don't know which users are allowed to use it. If you do that, is only the root user allowed to use it? Is only the user that configured it allowed to use it? This to me is unclear. So one of the things I can do, I have the power to do, is say help topic or help apropos. No world readable. Oh, but unfortunately nothing matches. So let's just continue. What do I even have for help? Oh, well, it would show up in help apropos. All right, moving on. So nothing here yet. Let's add the configuration. We're going to use the IP address from Ubuntu guest 1. Okay, so now we've got a new term. So This is just a ACL to track and create logging for any time the management server interacts with the device. So we're not going to be restricting any traffic. We're not going to be throwing any traffic away. So we're going to be accepting all other traffic. Okay, so now we've got to apply it to a family INET logical unit. So this will be a good lesson. I'm going to apply it the way they appear to be doing here. I'm going to apply it to the interface facing the guest one server. So oops, I gotta do a run show int descriptions. So, oh, right, okay. Well, it's gonna be the 1-2 router 1 because that's the fewest number of hops. So I'll apply it there. G002 is the port that faces router 1. Set filter input, Icmp syslog, perfect. So here's our filter. This is a really nice filter straight from the docs. I think it's gonna work much better. Oops, except I made a typo here and I did .3 instead of .2. So I apologize to anyone screaming at the screen. And this is kind of a good point to make too, because if I did this in production and it was a ACL meant to deny traffic and not just log it, this could have caused a very, very big issue. So it's definitely, I would advise being very careful with any firewall filter you add, especially ones that throw traffic away. Oh, right, I'm in set, so I want to be in edit. Okay, show pipe display set relative. Oops, and for some reason, let's do a rollback 0. Show pipe display set relative. Edit firewall family INET. Show pipe display set relative. Edit filter Icmp syslog. Term Icmp match. Delete from address 3/32, and now it's going to be 2. Oops. Perfect. So commit and quit. Now it's going to work as expected. So let's go down to the verification steps. So it's going to be show log messages firewall any, and we've still got, oh, no, we don't still have it going. Okay, so now we've got the ping going, so we're going to see some matches. There we go. And one thing to remember is that this is a log file. So we can do a monitor start. And since we're pinging, we're going to see a real-time log of each of our pings. Looks like it abbreviates it for us, though, if we've got too many redundant messages. But these are all just pings, so I'm surprised they're not to. Okay, so this looks like the pattern is they're going to show us it 3 times, but then if it's the same 3 messages, they'll just show us an abbreviation, but they'll only do that 1 time. So you can see there's a clear pattern: 3 messages with the full information, then a message that says this message here, this last message was repeated 3 additional times, but then, oh, it looks like here it made it in a 4th time somehow. But the pattern looks like it's pretty clear. I'm sure that's all configurable and stuff, but yeah, this has been interesting. So I would say that this has been a success. So I will close this and move on to the next one. So this is configuring statistics collection for a firewall filter. This example shows how to configure and apply a firewall filter that collects data according to parameters specified in an associated accounting profile. In this example, you create a firewall filter accounting profile and apply it to a firewall filter. The accounting profile specifies how frequently to collect packet and byte count statistics and the name of the file to which the statistics are written. The profile also specifies that statistics are to be collected for 3 firewall filter counters. Topology: the firewall filter accounting profile specifies that statistics are collected every 60 minutes and that statistics are written to the file. Statistics are collected for counters named that. All right, so I think we're good to go to just do the, yep. So we're gonna have to use a different, oh, we can do a number of things. So let's see where it's applied. Okay, so it's applied to that port. So one thing I guess I was expecting to see in the last one, because remember I posed a question, oh, will this work or not for the iNet interface? So let me do a monitor stop. Okay, so looking at the show configuration firewall filter, pipe display set relative. Oops, I've got to specify the name of the filter. I don't even know what it is. Pipe display set relative. Okay, so here it is. And this is better anyway because I can't see the very edge of my screen. So oh, okay, yeah, this will be fine because it's just going to be matching traffic. So I have initially thought, oh, the traffic is destined to 172.16.0.4. Therefore, if I put the call of the statement, and let's take a look at that. Oops. On the interface going to router 1 here, which does not have that source address in the packet, you can see that this is the address, the interface with that source address in the packet. What I had initially thought for a second to data would say, Star Trek First Contact, look it up, it's a great scene. But I had initially thought that, oh, it would have to be called here because the destination address in that Icmp traffic is there. But nope, that's not at all how it works. I know that's not how it works. It just kind of was my initial thought. So it's just looking at all traffic coming in, and we can see that the matching criteria says that we're gonna look for any traffic that has this address in it. So whether it's the source, whether it's the destination is unspecified, but as long as it's got this address, as long as it's Icmp, then we're gonna count the packets, we're gonna log them, we're gonna accept them, and then anything that doesn't match up here, we're also going to accept. So that has nothing to do with the destination address. You can put it anywhere where it will, you can put it, of course, in multiple places, but putting it on the interface that has the destination address of the ping address of the ping packet is completely unnecessary. It passes through that interface on its way to another interface, but you've got the monitoring set up here so it will see it. It doesn't have to terminate on the interface in order to get the monitoring. In order to match the packet, it can pass through it seamlessly and still match those attributes in the packet. All right, so let's continue on with this. Let's continue to do it on router 4. Oh, and this actually looks like it's going to be counting up the OSPF packets. So let's do this on a different router so we can see. Yeah. And then we will be using, I think, because these are going to be from the source address. So if I do a show Ospf neighbor, we could see my neighborship subnet is that class A private space. So we'll be using that for the source address 10.0/16. Let's do that on router 3 so that we've got different filters on different routers. Okay, so, oh, yep, I'm in the right hierarchy. I just need to move on to the next term. Okay, so this was not a term. This was a kind of global setting to the whole firewall filter. It's not something that falls under a forward firm. And let's take a closer look at what this setting actually was. So it was accounting profile. Okay, so we've got to make a name for our accounting profile. Oh, no, we're not gonna be making a name for it here. What we're gonna be doing is, this is kind of like a firewall filter within a firewall filter, except for it's not a firewall filter, it's an accounting option. So here's the name of the, yeah, so it's a filter profile, which is an accounting option. So here's the name of the filter profile. That's what we're going to be plugging in here because we're calling this whole filter into this firewall filter. We're plugging in the accounting options into the firewall filter. Oops. Perfect. Got all three of those statements in term one. So time to move on to the next term. Oops, it's going to be a dash, not an underscore. So that's, of course, a little bit of a security risk, because if I do a show route 10.0.0.0/16, you can see my space only goes from 0, 1, 2, 3, 4, 5, and it might go to 6, because no, 5 is the highest, because 5 is the local one. So if it did have a 6, it would be on another device. So yeah, so it's got six of those IPs, 0 through 5, but that's just 6 IPs. So in a subnet, that for each bit in the networking portion, you get to have 2 networks. So if we've only got 10.0.0 through 10.0.5, and we did a /16, we're allowing a lot of extra subnets to be matched by that statement that do not need to be matched. So instead of a /16, we could do not a /17, because that wouldn't give us enough. That would only give us 2 extra, not a /18, because then we only have 4 extra, but we'd have to do a /19, and then we'd only be matching 0 through 8, and then .9, .10, those would be rejected. As it is now, .9, .10 are accepted, which is less secure, I think. So in fact, I'm going to go and make that change after I, oh wait, no, sorry. Yeah, so it's right here. So I'm going to go ahead and make that change. I'm going to make this a /19. So we're going to allow 8 network addresses here to be used. And that's good, because we're only using 6 of them, 0 through 5. So we've only got 7. We've only got 6 and 7 are the only extra ones that could be sent and accepted. Whereas if we just use the full 16, we've got 6 through 255 are extra ones. Oh, wait. No, this isn't right. I have to be /18. Let's take it a bit slower, and let's look at the actual bits. So we've got 10.1234, 1234.1234, 1234, and then our network is going to be, we've got .0, which is up there already. Then we've got 1, we've got 2, we've got 3, we've got 4, and we've got 5. Okay. So we want to allow there to be networks that can, so we want to allow particular networks and then not allow particular networks. So anything that is a source address 10.0.0.0.0, but where the network portion of that, so here, matches is all zeros. So we can see our network 5, which is right here, that's not going to match this because it will have this bit on. So we can do a slash 16, 17, 18, 19, 20, 21 and be good. There we go. So that's what is possible there. I think I might need to delete this 16 here. Yep, show pipe compare. There we go. So that's going to be what will be the most specific to overcome some sort of security risk by allowing too many allowed IPs. All right. Okay, so now we're going to edit the interface going to router 1. Oops, so I think I did a typo here. So this file does not exist. So, I thought it would just create it. Usually it just creates the file. Like that's the point. Like when you do a trace options, the file doesn't have to exist already. You can just create the file. Like it'll just create the file for you. So I don't know why it needs to have this file pre-exist. I mean, I can just do a run file and then create or file make something. Yeah, I think there's a way to make the file. Let's see here. Like this. Nope. Okay. Well, do a commit check again. I want to see that error some more. Okay, so edit accounting options. Show pipe display set relative. All right. So there's the file. Let's look at that in more detail. So this file has to pre-exist. All right, so you have to have that file pre-exist somehow before you commit this. So that's okay, I think, because I think there's a way I can get that to pre-exist. What if I do a run start shell? And then copy the name of this file. There we go, and then do vi for this file name. There we go, and then a WQ. So now we have that file, but it's got no lines or characters. It's just, so if I do a, oh, it took me out of, oh, it took me out of my, let's see here, show pipe compare. Yeah, it took me out of the configuration. So what if, can I get back into that process ID? So configure private. Okay, I don't know how to get back into that process ID. Oh, maybe I need to like exit or something. Yep, okay, I needed to exit. So I'm gonna do a show pipe compare, and there we go. So now I've got that file. I'll do a run file list. There it is, commit, and hopefully that is, so did I spell it wrong or something? A-C-C-O-U-N-T-I-N-G. The file does exist. So, oh, okay. Okay, so it looks like I've got to create that file under var log. So let's do that. We'll do a run file delete on the one that's currently there, just so it doesn't get cluttered up. Perfect, and we'll do a run start shell, and then cd var log, and then vi for that. Okay. Oops, so still thinks that it does not exist, even though if I do a file run file list var log, you can see there it is right there. So I followed all of the instructions here. Unfortunately, there's some issue. It could be because I'm using a virtualization instead of live gear, something like that. But unfortunately, this, I guess I want to say that it didn't work. I kind of hate to give up, but if it's a dead end, it makes sense to give up. Giving up is important sometimes. So yeah, everything looks good. It's just that this file says that it does not exist, even though it does exist. So there's some both, or it doesn't exist in the right folder, or there's some sort of issue there. So I'm just going to roll this back. Exit. I might do a help apropos on accounting options. So yeah, let's do a help topic on that. Oops. Yeah, on file. Perfect. There we go. So configuring files. An accounting profile specifies what statistics should be collected and written to a log file. To configure an accounting data log file, include the file statement at the edit accounting options hierarchy level. File name is name of file in which to write accounting data. If the file name contains spaces, enclose it in quotation marks. The file name cannot contain a /. The file is created in the var log directory and can contain data from multiple profiles. All accounting log data log files include header and trailer sections that start with a # in the first column. The header contains the file creation time, the host name, and the columns that appear in the file. The trailer contains the time that the file was closed. Whenever any configured value changes that affects the columns in a file, the file creates a new profile layout record that contains a new list of columns. So it looks like it's as simple as just, oh, this could be it. Or nope. Maybe I need to do that non-persistent. Huh, okay, well, those look like just specific options. It looks like it will just create automatically. All you need is file name, and then you need maybe files one. Maybe I needed more information under there. I'm kind of tempted to try it again. I really hate to just give up. So I think I printed out a show run so I can even just grab it. Nope, I'm gonna have to type it all out again. But I'll just do some copy pasting this time. So yep, all this can just get copy pasted in. But I just want to try it again because it strikes me as really odd that it was not able to go in. I almost wonder if I made a typo or something. That's the first thing I was looking at, but it looked fine. Okay, I'm just going to make it easy on myself and have it be a /16. We'll go back and set it to the other value if this turns out to not be that difficult. Otherwise, I'd like to reduce the complexity for now. Okay, so that's good, I guess. I just so sometimes if it just magically fixes itself, it's like, well, I'd rather it didn't do that because now I don't know if I can rely on it later. I'd rather it consistently do something that's unexpected than do something that's unexpected one time and then do the expected thing the next time. All right, so yep, let's go into file. So edit file. Oops. Oh, I can't go into edit when it's file. It said I could in the help. So let's try test. Yeah, let's just try setting the title of the file to be named test. Oh. Oh, because I overwrote it. So, yep, file test does not exist. That's so strange because the point of the command is to create the file. It's like, of course it doesn't exist because you were supposed to create it. It's like ordering a steak from a waiter. The waiter saying, you can't order a steak because you haven't gotten up and gotten the steak yourself. It's like, well, I don't know what the analogy is. I'd have to think about it a bit more, but it's definitely a situation that I hope I don't encounter on the test, because if I've run into something like this, oh man, I'm sure I will. All right, so moving on, let's just set that aside and move on to the next one. Configuring a stateless firewall to protect against TCP and Icmp floods. I think this will be really important to know. It is, unfortunately, I think this video is going a bit long. I kind of need a little bit of a break. It hasn't even been an hour yet, so I'll be able to get through these two, I think, and then I will come back. Why don't I just take a quick 1-2 minute break and then come back and get through these two, and then I can call that done and mark this topic complete. All right, I'm back, feeling a lot better. Just need a little bit of dinner. It's getting about that time, 6:30, 6 o'clock. So I'm ready to continue on with these two further firewall filters. So let's do a filter on router 2 now, and then we'll do the last one on router 1. Unfortunately, the filter on router 3 did not end up working, but we'll go to a new router anyways. So I'll just roll back what's on there because I don't know what the deal is. Oh, it looks like I already did that. So moving on to router 2, configuring a stateless firewall to filter to protect against TCP and Icmp floods. This example shows how to create a stateless firewall filter that protects against TCP and Icmp denial of service attacks. In this example, we create a stateless firewall filter called protect-RE to police TCP and Icmp packets. It uses the policers described here. When specifying limits, the bandwidth, okay, so I don't think there's a need to read any of that. You can apply a stateless filter to the input or output sides or both of an interface to filter packets transiting the device. Apply the firewall filter to any non-routing engine device to filter packets originating from or destined for the routing engine. Apply the firewall filter to the loopback interface. Oh, okay, so that's interesting. So this is to filter packets originating from or destined for the routing engine. So in the example we had before where I didn't know why it was dropping the Ospf neighbors, that must be why, because it was filtering traffic originating from or destined for the routing engine. So that makes a lot of sense that it would drop those because of that. Because this firewall filter limits routing engine traffic to TCP packets, routing protocols that use other transport protocols for layer 4 cannot successfully establish connections when this filter is active. To demonstrate, this example sets up OSPF between device R1 and device R2. All right. So here's the step-by-step. Okay, so let's just go right down to so configure OSPF. Oh, and they're adding the interconnect routes to OSPF. I guess I'm not sure what they're doing there. So they've got policy options prefix list. So let's see where they're calling this prefix list. Okay, so this is being used in the TCP rules. So the configuration for the stateless firewall starts with step 5. So let's start there on router 2. So we'll start by defining the list of trusted addresses. So this is what I was trying before, where I wanted it to be accessible from guest 1, but not guest 2. So let me pull those up again. So here we've got guest 1, and here we've got guest 2. So we'll see, oops, yep, so we'll be able to see that guest 1 can ping router 2. Guest 2 can ping router 2. Oh, there's no, oh, you know what? I bet you router 1 doesn't have, no, it's in there. Yeah, so it looks good to me. Oh, you know what? I had that example. So if I do a show Ospf Neighbors, oh, no, I did take that off of there. So what? Huh. So why am I not? Well, so instead of just asking why, let's do some initial t-shooting steps first. So let's do a trace route, and then let's ask a better why. Let's ask why it gets to this, but it doesn't get any farther. So let's go on router 1, and let's do a show route 2.16.0.2. So and let's specify the source address. Oh, okay. Well, that's even more confusing. What the heck? 172.16.0.2. Destination host unreachable. All right, well, let's try pinging this from router 2. Sure. So it's got it. Okay, so it made it over to router 1, but on router 1 is where it's having problems. So it is added to OSPF. Loopback 0 is added to OSPF as well. Yep, doesn't have anything fancy on there, like a firewall filter that could be messing with things. Let's see what Ospf Neighbors it has. So it's got everything, but we know that the problem is with router 1. So the loopback interface is up. Yep, all these interfaces are all up. So why is it not able to ping that? Can it ping any of those? Nope, it can't even ping .1. So I think it has to do with the routing table, maybe? The routing table looks fine. I think it looks fine. Destination host unreachable, reply from .6. Okay, well, let's go over to .6 and let's see if I can reach the host. So .6 is here. There we go. So what about sourcing from .6? Oh, .6 is the Ubuntu guest. I was thinking .5. So this .6 is saying that the destination host is unreachable. But it's giving it a gateway, so yeah, and the gateway is there. Let's see if we can ping the gateway. Okay, so here's the problem. Clearly, it can't even ping its own gateway. It can ping itself, but it can't ping across the wire. Let's take a look at why that might be the case. So it looks like it's cabled upright, but there is an issue with GNS that can happen sometimes where the wire just kind of tickles out on you. So if you just recreate the wire, sometimes it just magically starts working. Nope, that's not the case here. It's definitely some larger issue. Okay, yeah, everything looks fine. I guess I don't know what this UG means. Gateway, maybe? Yeah, so there's some kind of issue going on with this router. And I think it has more to do with just something glitching out on the Ubuntu server. So yeah, this one looks perfectly fine. But unfortunately, it looks like it's pretty much the same as the other one. So I don't know what the issue could be. Okay, well, ping myself. but I can't ping across the link. What if I ping the broadcast address? Yeah. So if I ping across the link, I get a destination host unreachable, which is interesting. Can I ping myself here? I can. What about across the wire? So now I'm just getting a timeout. So I think maybe if I reboot the Ubuntu Docker guest, it'll just un-F itself. I think it just got F'd somehow. So I'm going to try that. So it got forked. Just kidding. It got, let's see here. So that's itself. Oops. Well, I thought it was set up for DHCP, so I'm surprised it didn't. Yeah, it looks like it failed to get a DHCP up, but we know why from the previous previous video. But it was show DHCP binding. Oh, or show, what is it? Access. Yeah, show DHCP server binding. We still got that in there, even though the other one doesn't have it. So we got to give that up if we wanted to successfully pass that out again. Perfect. So now we'll pull it. Does that pretty much instantly. Or at least it did before. Yep, so it does that pretty much instantly. Aha, so now we can see what the problem was too. It's getting a default before it didn't say default there. So I think that's what the problem was. So hopefully it is now working. Perfect, okay. Yeah, so I think the problem was that there was some issue where the DHCP server was holding on to the IP, and then they kind of got out of sync somehow. But that was not too difficult to fix, and it was a really good troubleshooting exercise, I think. So let's continue on with that configuration now, and we're going to be having the device router 2 be only accessible from guest 2, sorry, guest 1, and not guest 2. Just as I planned here, but we're going to need to use the help documentation for that. Okay, so we're going to start with the trusted addresses. Okay, so now we're going to be trusting 192.168.0.2, and that's all we're going to be trusting. Oh. Okay, so here they're adding the direct routes into OSPF. Well, I don't know what they're doing here. Oh, they're configuring BGP. What the heck? Why are they doing that? Okay, well, I'm not going to set up BGP in my lab. I'm just here to learn about TCP policers, which apply to BGP, of course, but I'm only here to learn about it for remote management, which is, I thought, the name of this. Oh, no, never mind. This is going to be to protect against TCP and Icmp floods, which might be directly applicable to BGP. So yeah, this looks like it's probably something meant for BGP specifically. It's not meant for management. So you know what? Let's skip this one. Time is of the essence. So yep, and then this is the one that I wanted to do anyway. So I'm going to do top, and I'm going to do rollback 0, and then I'm just going to do this one instead. So yep, it should be pretty easy. Edit, firewall, family, inet, filter, local, ACL, terminal, access, set from, source address, set from protocol TCP, set from port SSH, set port, oops. And we can leave out telnet because we don't want to accept that. It's not secure to do that. So So for this one, where we're denying it for all the other ones, we will set up set from port telnet because we want to specifically deny telnet as well as SSH. All right. Oops. And it looks like I changed the address on the loopback, or well, it's Juniper land, so I just added another one on there. I think I'm going to take that out. I'm not sure why they want that on there, but that's not going to be the loopback address I am using. Okay, so now I can go up, show pipe compare. So now I am good to commit this. Okay, so now that goal I had from the start, hopefully it's going to work now. Let's do the verification steps. Oh, yep, so here's where the verification starts. So let's do the clear firewall log, give fresh data. Okay, and now let's do from host guest 1, SSH, and R2 is at .2. Oops, and we've got to use a username. And R2 doesn't have any radius set up. So oops. And oh, yeah, I used the wrong source address. I just used what they gave us there, but I did not edit it to be relevant to my own topology. Okay, so, yep, let's get rid of this. All right, so now we can set it to something more relevant. Oops. Oh, okay. I wanted it to be /32. So this is a really good message for anyone watching this who's especially at the CCNA level, something like that. 127.168.0.2/24 has non-zero bits where bits in mask are 0. So let's look at that in more detail. So this is going to be 192.168.00000000010 because the 2-bit is toggled on. But I said that here I'm specifying a network address. So network addresses have 1s on in the network portion. And they have 0s on in the host address portion. So if I say this is a /24, which I'm saying here, I'm saying that these last 8 bits are all going to be toggled off 0. But I lied because I toggled on this bit. So it's not going to be a /24 because I don't have all the bits toggled off in the host portion. Now, hopefully I'm not confusing you, because it's not that you have to have all the bits toggled off in the host portion. It's that in this particular case here, you have to toggle, you have to give it a network address. And a network address is an address with all the bits toggled off in the host portion. This here is a host address. A broadcast address has all the bits toggled on in the host portion. So what this is saying has non-zero bits where bits in mask are 0 is that, hey, you didn't give me a network address, you gave me a host address. I need a network address for this part of the configuration. Okay, so let's do that. All right, I'm going to delete this. All right, and then this is going to be a /32. Perfect. So now hopefully everything works a lot better, and we'll be able to SSH from here. Perfect. So we can SSH from here. Oops, can I not? Oh, maybe there is radius on here. Let's see if radius is on here. So it has I think if you have a user account, you can no longer log in as root. You have to log in as the user account. You can only log in as root through SSH if there's no other account. And that makes sense. Like, you wouldn't want people to typically log in as root. Okay, so let's log in with the local account on the box, which uses public key authentication. Perfect. So there we go. It's all set up, good to go. So let's try it from, we'll skip this telnet section. And let's try it from the guest here. Ah, God damn it. I thought I just fixed that. Oops, that's 15. Yeah, I just fixed that. What the hell? What? Okay, so I think what's happening here is this is the rejection message we're getting for having that up. It might be messed up because it's automation, it's a VM or something. I was expecting a connection refused message. Let's roll back that configuration and see if I can get there without it. But the, oh, we got to do a rollback too. But the expected outcome was that it would not allow me to SSH in there. So that is the expected outcome. It's just I was expecting the message to say connection refused. Okay, so yep, now I am able to get in. Now that I have, oops, but I don't have my key set up there. So let's see here. So cd.ssh known host. So I don't even have a public key. Let's do an ID, or let's do a SSH keygen. Oops. Yeah. -T RSA-B 2048. Yep, we don't need a password for it. And then we're going to do a cat, or sorry, then we're going to do a CD, and then we're going to do FTP. Oops. Oh, okay. Let's do an apt-get install FTP. Might need to do an update. Oh, right, and we don't have. Yeah, we don't have external. Well, that's interesting because we could have. I could set it up. Yeah, I can set it up so that we've got connectivity to the outside world just by having it go through the lab. But I would need a new route. Yeah, so we've got 9 here. So show routes, protocol direct. So we've got this, so we can have a route saying that well, yeah, because what's happening is if I ping 8.8.8. here, I don't have a route for that. I don't have a default route. So I would have to set up a static default route. But if I did that, I could only pick one of these. Well, actually, I can set up 2 routes. So I can set up, oh, No, I only need it that way, because if it's coming in this way, the destination address is going to be fine. So let's do that. So let's do edit, configure private, edit routing options, static set route 0.0.0.0, and then it's going to be /0. Next hop is going to be 192.168.0.2. Commit. Okay, so now if I do ping 8.8.8.8, oops, but we've got to see if the oh no, it's not going to be that command. It's going to be this one. Oh, but yeah. So it should work. Why is it not working? Yeah, so it's not working because the return address. Oh, it's not sourced from the. I've got to do 2.16.0. Okay, so let's think about what's happening in the routing table. Let's do a show route 8.8.8.8. So it's a static route. It's going to send it out G009 to 192.168.0.2, which is here. So let's do a route 8.8.8.8 here. Is there a way to say like a route show or something? I don't think there is. But let's see what happens. So 8.8.8.8, does that match any of these? Well, it only matches the default, that's it. So it's going to go out to the cloud. So yeah, but the thing is, when it gets out there, so I've got to set up. See, I thought I had, I thought it would, because it goes to my router. Oh yeah. So I got to set up my router. This I did before. So my router's got NAT, but it doesn't have a route. I can do this. There's nothing preventing this from being possible. So I didn't have to do this for, well, let's see here. So advanced administration, router status is your advanced setup, static routes. Yeah, so you can see I did have to do this. But the, yep, so the gateway, okay, well, why, okay, wait, but why is it, because well, why can't I do it from the router 1? Yeah, why doesn't this work? Because I have a route now. It's going to go over there, and then I've got a route here that goes out to 1.1. So then when it comes back to 172, yeah, it should be fine, because the source address, yeah, and then it's just going to be NAT. So like this is just all, like when it leaves, yeah, it's going to be all different, but it's going to NAT it to my public IP. So I don't have to worry about this addressing. There's a hard line. I need to worry about this side of the line, not that side of the line, because it gets natted, and then that's all handled by the ISP. Here, it's before it's natted is what I need to worry about, but I seem to have a perfectly fine setup for that. Okay, so it's getting to .2, but then from there, it's not getting to this. Yeah, and .2 is here. So I have config .2, so ping source. What is it? It's not source. -S or -I. Maybe -I. Okay, yeah, that's how you specify source address. So, so here's the problem when it's, yep, and this makes a lot of sense because the static route, or sorry, not the static, the static route on my home router is only allowing it for traffic to the 172 subnets. I think. I'm actually, I think I'm on the right track with this. I think I can figure it out if I just go at it, but I'm just, you know, it's Friday. I had a day of work and stuff. I'll be honest, I'm completely wiped out right now. So I'm going to stop the video here. Unfortunately, we didn't get all the way through having it work from, oh, actually, no, before I stop, let's just continue with this exercise. Let's, because we did see that it worked from one and it did not work from the other. So let's do a show system rollback compare 1 0. Oops, so we added a static route. So let's do 2 0. Okay, yeah. So we took this off and we saw that we could SSH to it just fine with that off. So that's what we did. Yep, but of course it just didn't have a user account set up. So that's all I was trying to do. So if we put that back on, come on. Yep, if we put that back on, come on. Yeah, so when we put that, what? Okay. But it's rejecting it. Oh, you know what? I think the filter. Okay, so I never put where it was applied. So let's do a show configuration rollback, or show system rollback pair 4 0. So here's where it was applied. Okay, I just never applied it is why it was never working that way. So Oh, the commit probably didn't complete yet. Nope, commit wasn't complete yet. So, oh, okay, now it's really confusing me. What? What? Oh, was I going for the wrong one? No, I was doing that too. Yeah, works too. Oh no, I was. So yeah, I was configuring .1, but I was testing to .2. But the things I was expecting to be true for .2 are going to be true for .1. You can see I have no problem logging in from here because it's sourcing from 192.168.0.2. But here, where it doesn't have that IP, we got problems. So that's, I think, good. Let's go the extra mile, even though I wasn't lying about being kind of wiped out, and take a look at the firewall logs. So hopefully I have those on .1 and they're not just all on .2. So let's do a show configuration, pipe display sets. Well, I might only have them on .2. Yeah, but it looks like I can just roll back one and then show pipe compare. Yeah, and now I'm back on my feet. So if I now do this as I was attempting to do before, we're all good. Oh, you know what? No, because it'll evaluate until there's a match, right? So it'll go through and go, okay, there's a match here, so it's good. Because then it'll go right to the accept, and then it won't continue to look at other terms. think. Okay, that really confused me. I really thought I was understanding what was going on until I saw that. So why is it? Okay. Submission unreachable. You know what? Maybe it cut off the Ospf Neighbors. No. Oh, it looks like it did mess up one. Yeah, it looks like it messed up an Ospf neighbor for some reason. To R1. Oh, you know what? It's because it's because I've got this this funky one that I just kind of made up on my own on there still. So let's get rid of that one. Yeah, and that one kills Ospf neighborships. So okay, so now this neighborship is no longer going to be in a init. I really hope they have pipe refresh 1 on the test. That would be so nice. Okay, so now loading the full, perfect. So now it's going to behave in the way I would expect. Yeah, so I'll close router 1, don't need to do it anymore. And now we'll see that it's behaving the way I expect it to behave, where it is accessible from Ubuntu guest 1. Perfect. But it is not accessible. Let me log out first. Oops, it's going to be exit. It's not accessible from Ubuntu guest 2. And this is .2. There we go, no route to host. So that's kind of an unusual message. I think typically you'll see connection refused. So I'm not sure what's going on there. But the expected behavior of being able to access it from guest 1 but not guest 2 is demonstrated. Now we can see in the firewall log that we were trying to use .6 so we're getting an action R, and I'm guessing R stands for reject. I'm kind of surprised we were getting the action R for these source addresses that do comply with the oh, okay, maybe because of the pings. Oops, that's not the right address. Nope, so that's fine. What the heck? Yeah, so I'm not sure what those R's are for that address that is permitted, but let's see if we can get an extra R by trying to log in with guest 2. So our last R was at 4.8, or sorry, 4.6. Let's do a clear. Okay, and now let's make it more obvious when there's more entries. So now we got one because the source address did not match. Let's try from here again. So yep, now it's working as expected. We see a log entry and we see the action was rejected when the source address was 0.6. We don't see any log entry, and we're able to happily log in without any problems because we have the source address that matches the filter statement that we used. All right, so yep, that's it. So kind of a crazy video. Went into it a little bit more than I would have liked. Hopefully this video saves though, because I definitely want to get this on record. Unfortunately, that last video is lost. It's about an hour of time, but it's not that big of a deal. It's just when I do my calculations on how good I'm doing, they're going to be a little bit off. I think the last calculations I said that made it so I essentially need to I'll study 4 hours a day to go at the pace I was doing and have covered all the topics of the exam. It's going to be that I would need to study a little bit more than that, but because I lost some of the studying I didn't make it on video. But I am luckily now done with half of the topics in device infrastructure. So thanks for watching, and I'll see you in the next video where we learn about automation scripts using Icmp.